assessment asks us to draw the Newman projection for the molecule shown, the conformation shown, looking down the AB bond. Our chemist here is going to help us orient our picture, and I've gone ahead and labeled the hydrogens on the front carbon A as 1, 2, or 3. The first decision we need to make is whether we want to use the first carbon A of our Newman projection to look like the letter Y as being right side up or upside down. What you'll notice is that hydrogen 3 is in the plane of the page and is close to the viewer's chin. And so for that reason, right, if we think about I'm looking down the bond here, this carbon here, or this atom here, is actually next to my chin. If I look down this one, you'll notice that this atom is next to my forehead. So we know it's not that structure. We're going to start with this one for our Newman projection. And in fact, we already know that it's H3 that is by our chemist's chin here. Right? What we also notice is that H1 is on a bold bond that's sticking out to the left side. It's closer to our viewer's left ear. So if I'm looking down this bond in the same way, we're going to draw that hydrogen over here. That would be H1. H2 then is this one here. At this point, we can draw the circle for our Newman projection, and now we're ready to do what's in the back. First thing you notice is that at carbon B, which is behind, we have the methyl group in the same plane as H3. And so we can draw that here. That's going to be our CH3 that's coming off of carbon B. We're going to have a hydrogen here and a hydrogen here, showing that what we're representing here is an eclipsed conformation. How do we know it's eclipsed? By looking at this structure here, because our bold wedged bonds are both at the top of the molecule coming forward, our dashed bonds are at the top of the molecule going back. This is the Newman projection looking down the AB bond.